Hi, my name's Andrew O'Callaghan. I'm a student of Climate Change Impacts and Adaptation at the University of Edinburgh, and I'm currently living in Cork, in Ireland. The following presentation will assess the potential vulnerabilities and impacts of climate change for the Cork area. Located on the south coast of Ireland and built on the River Lee, Cork is the Republic of Ireland's second largest city. The city centre is situated on an island that is created by the splitting of the river into two channels before it flows into Cork Harbour. The city itself is home to 120,000, with 300,000 more living in the greater Cork area. The centre contains a mixture of residential buildings, offices and retail outlets. University College Cork is located on the south bank of the River Lee, with a substantial amount of the surrounding premises devoted to student accommodation. Areas on the outskirts of the city, once home to manufacturing facilities, are now primarily devoted to IT and digital technology companies. The harbour area contains one of the largest gatherings of pharmaceutical industries in the world. Most of these are located on low-lying coastal sites. The port itself is of significant economic importance, located close to shipping lines to the rest of Europe. The sheltered topography of the harbour also make it popular for a variety of recreational and tourist activities. Outside the city and harbour area, there is an abundance of fertile countryside that is ideal for livestock and crop production. Cork has a temperate oceanic climate that is strongly influenced by the North Atlantic drift, producing milder winters and warmer summers than would otherwise be expected at this latitude. It has generally mild weather throughout the year, with few extremes in temperature and abundant amounts of rainfall. The weather station at Cork Airport provides climate averages of the last 30-year period. The average annual temperature is 9.9 degrees Celsius. The mean temperature during the winter months is 5.8 degrees and 14.6 degrees in summer. The mean monthly rainfall is 102 millimeters, with 362.3 millimeters falling in winter and 85.5 during the summer period. Cork is particularly susceptible to flooding events due to its low altitude, proximity to the River Lee, and coastal location. The city was once a collection of marshy islands on the river delta before the waterways were built over to form the current street network. The city has experienced many flash flooding events in the past, most recently in October 2015. These typically occur when there is a combination of high tide and high precipitation over a short period of time. Major flooding events in both 2009 and 2014 caused millions of euro worth of damage to city infrastructure. Water supplies were cut off to large sections of the city after a water treatment plant became submerged. The university sustained widespread flood damage and was forced to close for a week. While the prevailing maritime climate moderates the effect of extreme temperatures, Cork has not been completely free of such conditions in the past. In the summer of 2006, Cork was affected by a heat wave, which lasted from the beginning of June until the end of August. While the heat-related human health problems observed on the continent did not occur in Ireland, the hugely reduced rainfall, which was 83% below average for June alone, resulted in significant soil moisture deficits, with subsequent yield losses for the agricultural sector. The Intergovernmental Panel on Climate Change Fifth Report predicts that the Northern European region will experience temperature increases and elevations in rainfall under all representative concentration pathway scenarios, with strongest warming in the winter. Precipitation projections vary seasonally, with agreement of a net annual increase in Northern Europe, despite a reduction during the summer months. The most recent region-specific projections produced for Ireland by the Environmental Protection Agency are based upon the older IPCC Special Report on Emission Scenarios Markers of the 2007 Fourth Assessment Report. In the EPA assessment, mean ensemble climate change predictions were calculated using three separate global climate change models under all emission scenarios across three time periods, the 2020s, 2050s and 2080s. This table shows the mean temperature increases for each season and time period based on the means calculated by the EPA. There is a progressive trend of warming, with the greatest amount occurring for the autumn period. This graph depicts the predicted temperatures for the 2080s. The bars represent the mean ensembles of all climate model predictions and scenarios, with the squares and triangles representing A2 and B2 scenarios respectively. Increases of 2 degrees or more are predicted for all seasons. Average summer temperatures may increase by as much as 3 degrees by the 2080s under an A2 emission scenario. In regards to precipitation for the same time period and ensemble prediction for the 2080s, rainfall is expected to increase by 13 to 18% during the winter months. A decrease between 14 and 25% in the summer is predicted for Ireland as a whole. However, the report suggests that the south coast where Cork is located is likely to experience a 30 to 40% decrease. In terms of extremes, there is a lower likelihood of Cork experiencing major heatwave events over the coming century, compared to the rest of Europe. This is mainly thanks to the maritime influence which buffers such extremes. However, the EPA expects heatwave durations to increase by 3 to 4 days per decade, with an increase in the longest dry period under an A2 scenario. In terms of extreme precipitation, the EPA also predicts that heavy rainfall days will increase under an A2 scenario. Likewise, the IPCC fifth report expects increases in heavy rainfall events during both summer and winter under RCP 4.5 and RCP 8.5 scenarios. The combined effect of sea level rise and precipitation increase, as predicted by the IPCC and the EPA, suggests that Cork will experience increased coastal and river flooding. The city centre and adjoining harbour area contain a substantial amount of economic assets that are highly vulnerable to such changes in climatic conditions. This poses a significant threat to port facilities and nearby employment areas, which are of extreme importance for the local and national economy. Similarly, a substantial amount of crucial transport, electrical and water infrastructure services are at risk of sustaining flood damage under all climatic projections. Increased risk of coastal flooding negatively impacts the port's viability as an attractive location for businesses and industry to set up. Disruption to businesses due to flooding and extreme weather events could reduce investor confidence to place assets in affected areas, as well as increase the cost of insurance for businesses. The predicted northerly shift of tourist destinations could suit Cork in the medium term, as traditional holiday locations further south on the continent gradually become less comfortable in the summer months due to rising temperatures. However, rising sea surface temperatures are predicted to impact the Celtic Sea in the longer term, resulting in a destabilisation of the coastal marine ecosystem, which could have knock-on effects for Cork Harbour as a tourist attraction. Predicted climate change suggests a mixed outlook for the agricultural sector in Cork. Increases in temperature propose that crop yields could increase with longer growing seasons. Expansions in dairy production are also expected by the EPA and the IPCC by the end of the 21st century. However, summer drought is likely to become more common with decreases in precipitation. Comparably higher incidence of drought in southern Europe could result in agricultural sectors at higher latitudes, like Cork, gaining a competitive advantage. As part of a highly globalised economy with a high proportion of multinational corporations operating in the area, Cork is particularly sensitive to transboundary impacts resulting from climate change. While certainty surrounding global economic impacts of climate change is limited, losses are expected with increases in global warming. Such losses would negatively impact Cork's open economy. Compared to the rest of Europe, Cork's energy supply is vulnerable due to its heavy reliance on fossil fuel imports, which make up 90% of net energy use, combined with its geographic location at the periphery of the European energy grid. Any instability in continental Europe's energy supply would have dramatic consequences for Cork. According to the International Energy Agency, there is an increased likelihood of damage to energy infrastructures under the predicted rise in extreme weather conditions for Europe. This could lead to a disruption of energy supply for Cork in future.